Hello everyone, this is Team Gohan, which includes Sai Pranav, Subodh P. Rain, Tejas C., V.S. Navneet Khanna as the team members. Crop production of different states in India is the topic which we choose for this project. We have collected the dataset from the year 1997 to 2015. It includes data of different states. A state-wise crop production dataset. It has 7 features that we can make use of. It is an extremely large dataset that contains crop production every season in every district of every state in India for the period 1997 to 2014. From the 7 features, it can be observed that the columns state_name, district_name, crop_year, season, crop_year are categorical and columns area in production are numerical. This dataset was obtained from data.gov.in. It can be validated using similar datasets from data.world, medium.com and agricoop.gov.in. Column details. Data visualization. Here we use Seaborn's regplot. This method is used to plot data and a linear regression model fit. There are a number of mutually exclusive options for estimating the regression model. From the above graph, it confirms the fact that for the most part, production linearly increases with area. As can be observed above, the most commonly grown crop among all the crops grown in all the states over the years under consideration is rice. Wheat is also one of the important, commonly grown crops in India. Here we isolate the most commonly grown crop, rice, from the rest of the dataset. The production column is divided by a scale factor of 10,000 for the purpose of normalization. Normalization is a technique often applied as part of data preparation for machine learning. The goal of normalization is to change the values of numeric columns in the dataset to use a common scale, without distorting differences in the ranges of values or losing information. Normalization is also required for some algorithms to model the data correctly. Train_test_split is a function in sklearn model selection for splitting data arrays into 2 subsets, for training data and for testing data. With this function, you don't need to divide the dataset manually. A random forest is a meta-estimator that fits a number of classifying decision trees on various subsamples of the dataset and uses averaging to improve the predictive accuracy and control over fitting. A random forest is an ensemble technique capable of performing both regression and classification tasks with the use of multiple decision trees and a technique called bootstrap and aggregation, commonly known as bagging. The basic idea behind this is to combine multiple decision trees in determining the final output rather than relying on individual decision trees. Random forest has multiple decision trees as base learning models. We randomly perform row sampling and feature sampling from the dataset, forming sample datasets for every model. Linear regression is a machine learning algorithm based on supervised learning. It performs a regression task. Regression models a target prediction value based on independent variables. It is mostly used for finding out the relationship between variables and forecasting. Different regression models differ based on the kind of relationship between dependent and independent variables they are considering and the number of independent variables being used. For predicting wheat production, we use random forest regressor again. We use n_estimators equals 100, which means that the number of trees considered in the random forest is 100. The training data is fed into this random forest model and prediction is done on the testing dataset. The accuracy obtained on the testing dataset is seen above as 96.76%, which is very satisfactory. Conclusion: this project focuses on the prediction of crop and calculation of its yield with the help of machine learning techniques. Random forest classifier was used for the crop prediction for chosen district. We built a model for crop prediction from the collection of past data. The proposed technique helps farmers in decision making of which crop to cultivate in the field. This work can be employed to search out and gain knowledge about the best crop that can be cultivated to make an efficient and useful harvesting. The accurate prediction of different specified crops across different districts will help farmers